And everything you've seen, it's pretty impressive. But did you know that there's another part of the world of technology that's equally important, very deeply important? It's the stuff that you generally don't see, right? And this is the world of big data. We now have the ability, using technology, to comb through millions, if not billions, of pieces of information and generate useful, actionable intelligence from that. And to help us get a better sense of this world that you don't see, this world of big data, I'd like to call onto stage Mario Domingo, who is the co-founder and managing partner of Loop Natural Intelligence Solutions, which is a consulting company that employs a unique combination of data scientists, automation, and deep machine learning technologies. Ladies and gentlemen, Mr. Mario Domingo.
Thanks, man. Hi. Hello. So when Maria asked me to come and speak, I said, that's going to be tough. I'm coming from a future tech conference in London, and that means I have to leave a day early. Who am I going to talk to? So I was very anxious the last 24 hours, wondering, oh, how am I going to do this? Then the two presentations before made me feel better. It made me feel better because out of all of the celebrities that was shown, the person that got the most applause was Stephen Hawking. So I said, I'm in the right place. So I'm coming here to talk about deep learning and how it will help social good, how it will help enterprises and stuff like that. But allow me to go through it. There's the irony of all of this is the highlight of my presentation was I was going to demo my little engine, right? But no connectivity. Anyway, but we made it up. We'll work through it, and hopefully I can talk you through this. So let me start with this slide. This slide talks to you about two types of things. One is highly automated, very intelligent. The other one not so automated and is very manual, right? So when you're running an organization, when you're running an enterprise, when you're running a business, when you're running a government, either you run it like the ship above, the image above, or you run it like that image below. And you know that the image below shows you that your ship can go just a little bit farther than the image above, right? So that's what it's all about. It's all about harnessing technology. It's about harnessing data to the benefit and the social good of society. How can we innovate for social good? There's been a big global trend in the last few years, probably half a decade, towards e-governments, e-healthcare, and e-everything. As a matter of fact, if you saw the previous speakers, you will see the different types of e-everything that all about, right? And when you look at the amount of money that's being spent worldwide to enable these capabilities, to make a big difference. As Information Week indicates, most of these efforts have been top-down. There's a technology, they discover a technology, we push for the technology, and the application and the relevant uses of this technology are not quite spot on. And as a result, the technology becomes hype, and people brush it away because it's too hypey, so to speak. So allow me to talk about big data for a minute. So big data, for those who already understand, give me a few seconds here, it won't be long. Big data is basically almost literally what it means. It's big. Data before big data was labeled data. Imagine Excel. Imagine a spreadsheet. There are columns and there are rows, and there are labels for every column and every row, right? That's called structured data. Everything else that's not structured is big data. So what is not structured? A photo is not structured. The file has a label, but that's about it. it refers to the file. It doesn't refer to what is in the image. And what's in the image? It's you, it's your friends, it's the label of Coca-Cola, it is the location of where you took your pictures, and so is the case with videos, and so is the case with voice, audio, sounds. All of that is unstructured data. So when you look at all those, there's a big propagation of that type of data. You see it all over the place. As a matter of fact, the majority of what you do now in Instagram, in Snapchat, is about images. It's about communicating, for pictures speak of 1,000 words. And therefore, the need is for us to have a better understanding of those types of data. And when you combine big data, you know, today, when you combine structured data and big data, it is more information than anything ever since the beginning of history of time. That's what we're looking at. And it's growing double every 2 years. That data is doubling every 2 years. But what to do with that data is not something that we can do traditionally as we do today using linear mechanisms. So everything we do in statistics and statistical functions is very linear. We have to have a different way of analyzing that data. That's when deep machine learning comes in. So deep machine learning is use of computational models for the data to speak to us instead of us speaking to the data. More on the concept later on, in order to deliver us real, valuable innovations. So let's talk about linear versus machine learning data, and then we'll get to the really fun stuff, which is the actual examples. So linear analysis will give us certain rules that will help us arrive at dog, cat. This is dog, cat, dog, cat. As a matter of fact, between Stanford, Harvard, and Oxford, the biggest challenge in big data is to find the cat. It is amazing at how difficult it is to find a cat in an image because of the shape of the cat. And the cat is the most popular image in the internet. So that can be done. We can label a cat and a dog. But machine learning does something different. Through a loop, that's not an advertising of my company's name. Through a loop, there is a recursive movement of the analysis across different layers, starting with small features, aggregating to a higher concept, like a tail, and the tail being part of a bigger image, like a golden retriever. And then from the golden retriever has this tail. Who happens to have these features of the tail? And that's how machine learning works. Machine learning takes granular views of feature sets from data, aggregates it into the next level of concepts, takes those next layers of concepts to bring abstracts, you know, at the next level. It is learning because you don't go seek. You don't go look for the result. The result will tell you what the data is all about. The human's job is to train the model and tell him, yes, that's a golden retriever. No, that's a Labrador retriever. So let's take a form of unstructured data called comments. Comments are unstructured because the semantic meaning is different for every context you come from. This is Yelp. Yelp is a restaurant app, so it allows you to go and provide comments. So in there, I go here once a week. The staff is excellent. Meals are reasonably priced, you know, for just $22. Okay, let's step back for a minute. Traditional analytics, even advanced analytics, is search-based. That means a human picks the word. And based on the word, it will generate for you a semantic understanding. Let's do something simple. Sentiment, okay? Sentiment, for a second, is positive, negative, and neutral sentiment. So I'm going to talk about Jollibee. Negative. Okay, that works. Or how about ganda? Or ganda. See, there's a semantic difference, right? So that is not getting captured. Deep learning allows you to capture a deeper semantic understanding of the words. And from there, and later on I'll show you how important this is, we're able to capture knowledge like we haven't been able to do. But it's not as apparent here. Let me show you something where it's really obvious. There. So we took our engine and we put Interstellar, IMDb, Netflix. Everyone said that this movie is sci-fi, right? When we took everybody's review, comments, and everything else that they said about this movie, the underlying sentiment underneath is it's dark, it's adventure, and it's emotional, right? I tried General Luna. I was going to show you if my engine was working. IMDb said it's action and history. Our engine said, according to Rappler's comments and everyone else, it's political, right? And the second was, you'd think it's history, right? It's cultural. And that's what, that's deep semantic understanding. All right. How about this example? I wanted to talk about getting engaged with this potential client, right? So obviously, semantic understanding is very, and the biggest source of semantic understanding is in comments, posts. One last example in this case, beef. If you were to put in our engine beef in the context of Yelp, which is the restaurant app, you will find that beef means pork, marinated, ground beef, shredded pork. So the way the model works is it predicts that when this word occurs, there's a straight correlation with or association with another word, and predicts with a percent confidence, say 90% confidence, that this other word will show up. And what it's saying is inside the context of Yelp as a data set, beef stands for even vermicelli noodles or something right there. It even stands for vermicelli noodles because that's the semantic understanding of what beef is inside Yelp. And then when we go to Amazon, beef stands for concern, downfall, drawback, criticism, right? And each of those threads that you see out there links to a deeper semantic understanding. So, in an ultimate example of big data, we have partnered with Rappler as part of our social good exercise to try to really challenge ourselves to do something really big. So we're going to connect to Weather Service, we're going to connect to Twitter, we're going to connect to United Nations data sets. We're looking for emergency services from healthcare institutions where we expect to find things like broken bones or scratches or wounds or cuts or things like that, and start finding the relationships, I call them, getting the genomic relationships across and be able to predict an event. The problem, the challenge that we have today is, in spite of the progress we've had, is we're very reactive. So the problem we're trying to solve is, what if we can go and pre-deploy, pre-mobilize our resources closer so that our response time is not in days or hours, but it could be less. So through the connect, that's why I'm going to ask you one thing. In a case of emergency, pass this on, please. When there are natural disasters, earthquakes, emergencies, disasters, typhoons, turn on your location services. Help me, please. No location, patay. Get it? So if you want to keep your privacy, I appreciate it. But when we are in a state of emergency, you guys, please tell your friends, tell your family, and yourselves, turn on that location services. Because what you say, we can go and try to understand how it works, and it'll be our own version of 911. What do you think? Yeah? Good. Very good. So what we will do is we will take the location data from Twitter. We will then take the context from emergencies and other data sets. We will enrich all these data sets so that we will deliver to the volunteer services a heat map. It's a prediction of an event. The event, we don't know if it's going to be traffic or it's going to be a flash flood or a landslide. We don't know. But what we can do is we can predict that an emergency event is about to happen. And if we can do that, we can keep training the model. And your reaction when you say, mali, there's no emergency. Did not work, there's no emergency. The loop will help teach the model and get it to learn better and predict better every time we do it. Okay? So, that's one of the social good we're working on. There's a second one. Through the idea of Gerard, one of our data scientists, and Amy, one of our scientists also, that are very much like you guys, very young people, very bright people, came up with this idea. The problem with outbreaks, the problem with epidemics, is that by the time we catch it, it's too late. It's already spread. There's already, widespread of the disease. So the idea is to develop a mobile app, right? Because in order for us to catch the epidemic, we have to catch the parasite. And in order to understand which parasite, we need laboratory and scientists. So there are probably a couple of thousands of them all over the world, these laboratories. However, there's far more need for them in the rural places, jungles of Africa, right? The mountains of the Philippines, where you need to have them, and you can't have them. So his thought was to do this, and this is what we're trying to work on. Take a picture of the parasite. Typically, these parasites are in pupu kaka, right? It's in Thai. Sorry, didn't mean to use a bad word. So what happens is you take a picture of the poo-poo, right? And the poo-poo, this picture, goes to Johns Hopkins and CDC and identifies the parasite. Identifies the parasites, looks at the database and sends a message back, whether please boil water, please have everybody take a shower, or please get rid of all organic waste. Please go, and all of the different actions that will be taken will be passed on back without the scientists being on site, without the laboratory, very expensive laboratory being on site. Yeah? The use of digital technologies, is to enhance performance and well-being, to reduce costs and resource consumption, and to engage more effectively and actively with its citizens. We are working with the government of Singapore. My company is a Singaporean company. I'm Filipino. We have a big Manila delivery center. We have a laboratory in San Francisco and another lab in Paris. And we also have data scientists here in the Philippines. And we help companies and we help governments, understand better how to use this. I was going to show you a demo of how we can do it. Can we go to it? So my team was a little bored. No, I'm just kidding. Elections being so important, we used LDA. Don't make me explain LDA. Who knows what an LDA is? Lateral dietrich algorithm. Oh, thank God. All right, so basically we used an algorithm. And this algorithm queries the database. There's no putting words in it, all right? We just went into the database, in this case, Twitter. And based on that, tell us what people are talking about, right? And so this first cluster that we're hovering is the Binay cluster. So if you want to talk about Vice President Binay, here are the key topics that are being discussed in Twitter today regarding VP Binay. So you will find things midway, such as, I don't know why ABS-CBN is there, but there is, Yoko, I don't know how to go there. Can we go to number 9? I'm not political, so I don't know how to go there. So let's go look at this. This is peace. And the funny thing is very strong relationship with budget, process, Bangsamoro, nationalist, BBL, national, and check this out, Mindanao, Comelec, right? I don't know what the relationship between peace and Comelec, but that's what the data is saying, right? And so what happens is the algorithm grabs the different concept at around 900 per hour and then correlates the data across the board. Let's just hit number 4 there. Let's see what number 4. Can you do number 4? All right, this is PH vote. So PH vote, these are the key issues. And so how may we be able to do that? We can identify the key issues depending on what people are talking about. That's what people are talking about. That's what it's showing. All right, let's go back to my presentation, please. In short, I leave you with a challenge. Next slide. I'll take over. Thank you. So the next challenge is you build a smart nation, right? Build a smart nation, not for the sake of the technology, but build a smart nation to change the world, right? I have found in my people highly talented individuals that makes me so proud to be Filipino. I was raised in the United States, you know, most of my life was in the United States, but it makes me so proud to see that my people are very, very good people. And you know what? The strength of science, technology, education, and mathematics in this country has to be put to greater good. And I cannot agree more with Maria when he says it begins with connectivity. Because connectivity will spur, you know, advancement in technology and everything else. So just before I say thank you, I hope you don't mind if I take a selfie with you guys. I don't get to present to young folks like this. I always presenting to old folks. Thank you very much.